Good everyone. Assalamualaikum warahmatullahi wabarakatuh. In this video, we will discuss the human-computer interface design as well as control design, especially control for accuracy of data input. My name is Gugu. Welcome to channel Gugu Learning. First, we will discuss about human-computer interaction as shown in the form of user interface and our user experience design. In particular, human-computer interaction, which is correlated with how humans or users behavior in interacting with computer. This means that every good human-computer interaction design, whether it's the user interface or user experience, should be designed based on its user's intended behavior. There are usually many factors influencing this. First, from the fitness theory. We have the task technology fit theory, which is first introduced by Goodhue and Thompson in 1995. Their task technology fit theory stated that technology will impact the user's performance if it matches the task it needs to perform. This shows that the human-computer interface needs to fit with the intended task for users. Another theory is the technology acceptance model, which combines user beliefs on the perceived expectation of technology's benefits and perceived effort in utilizing the technology, which is first introduced by Davis in 1989. He proposed two behavioral belief factors, perceived usefulness and perceived ease of use, which can affect the intention of a user in utilizing the technology. This theory implied that a good human-computer interface should also be designed based on the acceptance of the design to the users in terms of the usefulness expectation and ease of use of usage. Other factors, including users' circumstances. An example, users with disabilities are also some factors that needs to be considered when designing the human-computer interface. Now, based on the previous guidelines and the factors that affecting the human-computer interface design, we can establish 5 design objectives. The first one was a match between interfaces that we have that we design with task in line with the task technology fit theory. For example, when a user inputting a data to the systems, where an empty box is needed, then a text box design should match the task. And for processing and executing the input, a command button should also fit the task. The second objective is to ensure that the interface that we design is efficient. The design should use the space of the design form efficiently, make the design simple and efficient that the users will be able to easily understand and use the design. The third objective is to make sure there is feedback for each time that the user interacts with the interface. For example, a message that you have inputted this data or an error message that occurs when a user is making errors. The feedback is important as guidelines for easier interaction. The fourth one confirms queries or invocations that are actually useful to the users. The human-computer interface should be able to interact with the user, especially in providing the information that is useful to the users. For example, if the user querying yearly data comparisons, the user should be expecting a bar diagram that can show detailed information and can be interacted with. This confirms the perceived usefulness of the human-computer interaction. The last objective is that it can improve the productivity of the users, which is directly related also with the perceived usefulness, where the interface can enhance users' productivity when it deemed as useful. For instance, when the interface is flowing effectively, users will find it useful as well as easier as perceived ease of use also has direct correlation to perceived usefulness on the technological acceptance model. This means that the user's productivity level will increase over time. Now, let's look at what kind of user interfaces that can fulfill most of the objectives that we have just discussed. First is the natural language interface. This is where the users can interact using a natural language such as English language, just like when I'm talking. The natural language interface can also include an artificial intelligence processing such as the Google search interface. Now let's try to do a little bit of a demo here. Now we can use a Google search interface, as it also is an example of the natural language interface. So I can give natural comments to this Google search interface by typing on this interface, or maybe just using a voice command, clicking on the microphone here. Okay, there's a limitation on recording and using microphone, so I'm just going to type something here. For example, let's say I use English and get to nearest restaurant. Then it will directly give me the nearest restaurant near my location that is still open. Yeah, still open. So, or maybe, oh, sorry, it's closed already. So it will give me a navigation to the closed restaurant. Right. Okay. Other than that, I can also type something else. Now this will also. Okay, that's one. This will also kick in the artificial intelligence engines of Google search. So I'll just say I'm hungry, then it will show me restaurants also. Yeah, this means that it knows what I need. Yeah, and in here you can see on the right here, it also shows me the location of the restaurants that I can navigate to, and because I'm hungry, right? The second type of interface is the question and answer interface, where the artificial intelligence is usually in a form of a robot or bots, for example, a chatbot. Google Assistant or Siri or Cortana interfaces can also receive questions and answer them. However, the interface is a bit different with a true chatbot, like the newly established Google Nina, which is based on a neural conversation. It's way beyond traditional question and answer interface. Meanwhile, when we go look back, a traditional chatbot will actually provide users with options or sub-questions until they give the appropriate information to the users, such as, for example, we can type in or ask, how do I register? And the chatbot will answer like by asking more data one by one. For example, what is your first name? And we input our first name. What is your family name? Then we input our family name. What is your age? What is your date of birth? What is your address? And so on and so on. The third one is in the form of menu. Well, we'll not discuss this menu further since it's straightforward interface where most users like you guys should most familiarize with. And then the next one is the command language interface, like the command prompt on Windows. The interface has a built-in command where users can type these built-in commands to navigate or give commands to the systems. Now let's look at the following demo example. Okay, we're back here again. Now let's try to open the command prompt. Okay, I can ask to look at the command list. I can type help here, And as you can see, there are a lot of commands that are listed here. Okay, let's find some easier one. Okay, let's say cd, so it's a change the current directory. Okay, let's try to change the current directory. The current directory is C users ASUS. Now let's type in cd C. Go to the C. Okay, so now I'm on C. Now I can also change cd C back to the users ASUS. When I'm back to C users ASUS. So this is how a common language interface looks like. So I can type in these commands, but essentially the commands are already embedded inside the system and it's already listed. So all I need to do is to recall those commands. Another commonly used user interface is the graphical user interface, in which we have discussed using Visual Basic graphical user interface toolbox on our previous sessions. This graphical user interface also can affect the user's behavior in a way how a user can utilize graphics in the forms of diagrams and other types of graphics. The last type of the interface is the web-based interface, which have to be connected to a network. This user interface needs both client and server to connect the interface. The server usually contains the data and information that is needed by the users, which is built upon query languages, PHP, Delphi, Perl, and other types of server languages. While the client is the real interface that interacts with the users. Usually is built upon HTML5 or cascading style sheets or CSS. This interface can be a combination of previously discussed interfaces like natural language, comment-based language, or even graphical user interface. Now, next we will talk about the difference between user interface and user's experience. And why do we need both of these designs? Okay, I'll move myself here. Okay, first, the design approach for user interface is usually a top-down approach, while user experience is usually bottom-up approach. In designing the user interface, management will decide the flow of the information in the interface, making sure these information and data flow aesthetically. Management emphasizes on this smoothness by focusing in designing menus, layouts, buttons, graphics that supports the aesthetics that could create an interactive presentation for both the input and output interfaces. On the other hand, in designing user experience, users are the main source of design data, which will decide the flow of data and information based on their users' experience, making the design more efficient, effective, pleasant, easier, and more humanized to the users for both the input and the output design. This design is based on users' needs and requests, making their entire systematic journey from end to end, and also focuses on the usability of the interface. So, in conclusion, UI and UX actually complement each other, where the UX will make the interface more effective and efficient to the users, while the UI will make the interface becoming more interactive and attractive to the users. Now let's move on the next topic, which is the control designs, in particular on the accuracy of data entry. So how do we do that? First, we can use what we call the effective coding. Now, you should have learned about coding in the Accounting Information System courses. Codings can be in the form of sequential codes, mnemonic codes, block codes, or any other types of codes, which is already discussed in the AIS course. In this course, we will only discuss on why effective coding can make sure the accuracy of data entry. Coding is very useful in controlling data entry, and coding here refers to the coding of data, in particular, the primary key data, which should represent other attributes in a database. While data on master files needs to be entered wholly, data for transactions can use effective codings, therefore enforcing the referential integrity of a database. Now, how coding helps to achieve this? First, coded data are usually represented in a single data entry, hence make it faster in inputting data. Codes can also be embedded to the systems in the form of lists, search codes, or scanned barcodes or QR codes, which make the data entry lightning fast. Second, since coded data can represent other attributes, users do not need to enter those other attributes, therefore reducing the amount of data that needs to be entered. And third, most coded data are sequential in a way can be based on numbers such as sequential or block codes, or in combination of numbers and characters like mnemonic codes. Therefore, it will make data sorting more efficient during analysis and during data processing. And last, since coding requires less data to entry and faster, coded data only uses minimal amount of resources, such as memory for online processing and storage space for data storage. So to conclude, coding with faster, cleaner, sequenced data, and fewer resources for data entry will increase the data accuracy for data entry. Imagine inputting manually all data using keyboards compared to scanning a barcode, which is more prone for errors. Now, the second way to control accurate data input is to design an effective and efficient data capture. Following our previous example with barcodes, aside from the use of coding, the barcode scanning method is a way to effectively and efficiently capture data. It also provides us with little errors due to data is being recalled based on the barcode instead of manually inputting or typing it. Now, how do we do that? First, we need to decide what kind of data that needs to be captured. Is the data already available in the database? Then we can use query method to capture such data. Or is the data needed to be captured from a real world? Then we need to use some sort of manual input data method, such as keying using keyboards. However, nowadays, using artificial intelligence data capture, we can capture any kind of data, whether they are already available in the database or comparable to the ones in our database. For example, using a camera to take data as pictures to be recognized by the systems, or even capturing text and using an OCR technology to recognize the characters, read the data, and translate it to different languages. Second, we'll just let the computer do the rest, including data validation or even data capturing itself, where the system uses automated or probably artificial intelligence data capture engines to make sure that the inputs are already accurate. And third, avoid bottlenecks and extra steps, making sure that limits such as digits or text box spaces or the data size that are captured are appropriate. For example, uploading a video with 20 megabytes limitation on ALOC systems due to the availability of memory resources. Extra steps in capturing data also means extra efforts for the users, and it will also increase the likelihood of errors from happening. Fourth, we need to start with a good form. We already discussed this when discussing input form design, so I'm not going to discuss it here anymore. And last, following the 4 prerequisites, We also need to choose the most appropriate data capturing methods. For example, a high quality camera image for previously discussed OCR will be more accurate compared to a condensed WhatsApp process image, which is crap. Now, our last method is to make sure data entry is accurate by validating input transactions and validating the input data. Now, validating input transaction is to make sure the users do not submit incorrect data, such as conducting duplicate checks by comparing the current captured data with previously processed data. A username and passwords also make sure that only authorized users can input the appropriate data. For example, through a role validation method. Our previous input form design example using Excel also shows how the systems can automatically provide feedbacks when errors or inaccurate data entry occurs. For input data validation, I will include a video clip from my information systems auditing class, and now let's watch it.
There are several types of input control. The first one is the source document controls. Is basically where you have source document, and based on the data that is on the source document, you input the data or copy the data to the system. So it's kind of like manual process. And since it's a manual process, usually the control is done manually inside the source document. For example, a pre-numbered document. The second one is the data coding control. This is a bit different. A data coding control is where you put a digit to the coding of the input that you're going to input to the system. There are several types. We have the self-checking digits, for example. I'm going to show you how to do a self-checking digit here now. Okay, here now let's see. This is the code of the document that you are going to input. Example. Now, as you can see that we have 1, 2, 3, 4, 5 digits, right? And the number is 1, 2, 5, 6, 7. Now, what we can do is do self-checking digits by totaling this amount. Yeah. Totaling this the amount, and we'll get 21. Now, since the total number of digits is 21, we can use this as a self-checking digit. So we have 1, 2, 5, 6, 7, and 21, right? So whenever we input data, the computer will calculate directly 1 plus 2 plus 5 plus 6 plus 7, 21. Okay, so the data is valid because it passed the self-checking digit. Another way of doing self-checking digits is by rounding the number to the nearest exponential 10. So for example, we have 21, this means that 21 is 2 times 10, right? The nearest number is 2 times 10, which is 20. So what we can do is 20 minus 21, or we have 1 in here, like this. Yeah, so this is what we call the modulus self-checking digit. Of course, the real modulus self-checking digits is way more complex than that. You can see in the book, you can see in the chapter, one of the examples using modulus 11 or 10, if I'm not mistaken. The third input control is what we call the batch control. Batch control is not only for input control, but it can also be used for the process control. So basically what we do here is try to batch some of the inputs first, and then make a control based on the batch input controls. There are several types of batch control. For example, we have the control totals and we have the hash totals. Now I'm going to demonstrate you a few of those examples. Now here, let's see that we have 3 inputs. Yeah, the first one is file number 125671. Second one is 134561, and the third one is 123455. So what we can do is that using control totals means that there are three files, right? There are three files that is going to be inputted inside the system. So what we do is for these three files, we input it in batches. So these three will be inputted directly together, right? So for these three batches, there's what we call the control totals, which basically is going to compute the total amount of the file. So control total will put number 3 here because we have three files. That's what we call the control totals. Well, the second one is the hash total, is where we calculate the total amount of these numbers, yeah, of these three files directly. So we have 1, 2, 5, sorry, 1, 2, 5, 6, 7, 7, 1. We have the 1, 3, 4, 5, 5, 6, 1. And we have 1, 1, 2, 3, 4, 5, 5. Now, in the hash total, all of this number will be calculated like this. So this is the hash control for the batch input, these three file batch input, and this is the control total for these three file batch input. And the fourth one is the validation control. So validation control ensures that the data that you're going to input is valid. There are three types of interrogation for validation control. We have the field interrogation, we have the records interrogation, and we have the table or entity interrogation or file interrogation. Now let's look at the example of a few of the interrogation. Now let's look first on the field interrogation. An example is there. Okay, let's see. There's a transaction here and the quantity here. As you can see here, we have a control message. It's stated 1 until 10. So this means that I can input from 1 to 10. So I'll just input, okay, let's see, 8. Okay. So yes, doesn't the control is done. What about if I mistakenly put 11 here? Okay, so it gives me an error, right? It gives me an error. I have to try again. I'll just change it to 7. Okay, I'm done with it. Now this is called the field interrogation. So it interrogates the field based on the control itself. The control is from 1 to 10, the numbers that can be inputted. So if I put other than 1 until 10, then it will show me an error. Now the second interrogation is the records interrogation. So we have the 1, 2, right? So one of the record interrogation is after 1 and 2 is called the sequential record control. So this should be 3, right? So if I put 4 here, it will show me an error. Yeah. And the last one is the file interrogation or the table interrogation. An example is the label here. We have the sales trends or sales transaction. So it will actually show me the sales transaction file in here. So it makes sure that the label name is correct. Yeah? So that's called the file interrogation control. Yeah. Okay, and number 5 and number 6 is basically our validation controls. However, for number 5, they will show you a correction. Just like when you mistype and then on any Google application, right? And will show you the correct words from what you mistype or when you create a typo. Yeah. So it will automatically correct your mistake instead of showing you an error message. And the sixth one is still the same. It's actually validation control, but instead of only for one application, it can be given to all of applications inside the organization. So it's called the generalized data input system. So it has a standardized validation control for all forms of inputs inside all applications. Yeah, so that's the number 6.
That is all that we can discuss. Thank you for your attention. Do not forget to subscribe to my channel. See you in our next video. Good day. Assalamualaikum warahmatullahi wabarakatuh.